Now the first one we'll start with is the log base a of x. If u is a differential function of x and u is greater than 0, then your derivative of log base a of u is 1 over u natural log of a times du dx. Or u prime over u, notice that one, natural log of a. Now, we'll go back to our natural logs to find out. So this is like exponential. Exponential was u prime times e to the u, but if I had any other constant instead of e there, then I had to do the natural log of that. But e, the natural log of e, was 1. That's the same thing we'd have here. My, my base on natural logs is e, natural log of e, 1. And that's why we don't have to do it with natural logs, but you do have to do it here. Okay, so this one here, we're going to look at each of the piece. I have a is equal to 5, u is equal to x to the 1/2, so u prime equals 1/2 x to the negative 1/2, rewritten, it's 1 over 2 square root of x. And our derivative, y prime, would be u prime over u natural log of a. So here we go, dy dx equals u prime, which is this mess, 1 over 2 square root of x, u prime over u, so 1 over, and our u value is square root of x, times, and the natural log is at the bottom as well, natural log of 5. So we clean this nice little mess up. And so if you're curious, keep in mind this is u prime, and then this is u, and this is natural log of a. But the natural log of a goes in the denominator, the u goes in the denominator. This guy's in the denominator simply because, as part of u prime, he's in the denominator. So we get, now keep in mind, x times x, and we get 1 over 2 absolute value of x, natural log of 5. Now, for those of you guys going, why absolute value of x? Because we have to guarantee this x value is a positive value. But that's okay, that comes with the domain anyways, because x must be greater than 0. So it comes with the domain anyway, so I suppose we don't absolutely have to have that x. It can be 1 over 2x natural log of 5. So, but anytime you take something out from underneath the square root and it's an exponent, a variable, it has to be guaranteed to be positive. Okay, let's look at another example. Log base 5 of x minus 7. So you can always pause this one, see if you can do it on your own. Doesn't hurt. Okay, if you paused, then you'd come back and see how you did. If you didn't pause, well, here we go. A, which is our base, is 5. U is equal to x minus 7. U prime is 1. And our derivative, y prime, is going to be u prime over u natural log of a. So dy dx equals u prime is 1 over u, which is x minus 7 times the natural log of 5. And we're done. A little bit simpler than that last one. Okay, so derivatives of log base a of x going the long way. Oh no, we are not going to do it a long way. No, we're not going to do that. We're going to cheat. That's what we're going to do. Find dy dx if y equals log base a of a sine of x. We have this little power rule here that we can take this guy and move him down. So we get sine of x log base a of a. And this guy here is equal to 1. Now, this is where I remind you, your logarithms are an exponent. This is how you find exponents if you're missing the exponent. So it's read, when you have log base a of a, it's a to what power gives you a? 1. because they're exactly the same. That's why your natural log of e is equal to 1, because the base for natural logs is e. So anyways, this guy is 1, so we're left with y equals sine of x. And derivative of sine is simply cosine. Done. No, I don't want to go that well on this one here. I really don't. We can if you want on a day that we have nothing better to do. How's that? Okay, next one. The rule 10, power rule of arbitrary real numbers. If u is a positive differentiable function of x and n is a differentiable function of x, then your derivative of u to the n is equal to n times u to the n minus 1 power times u prime. So we've got to add a little bit more into this. So this first one, you can start going through, okay, so on this one, keep in mind the derivative is u prime times n to the u to the n minus 1. Basically, we got chain rule thing going on here. So u is equal to 5x, so u prime is equal to 5. And you're, okay. Well, that's what we needed. Everything else is normal stuff. So y prime equals 5. There's that u prime times the n, which is the cube root of 4, times your u value, which is 5x, to the n minus 1. Well, this is the cube root of 4 minus 1. So a little bit different from before is we can't subtract the 1. We did have to do a chain rule here because we had more going on in here. So it was more of a modified chain rule, because beyond that we really didn't, I mean, I would not have gone s of u equals, and I suppose we could have s of u, then you would have had u to the cube root of 4 power, and then you would have gotten s prime of u to be cube root of 4 times u to the cube root of 4 minus 1. And then you can see at this point that that is your derivative. But really what we need to know is that right there. What is u and what is u prime? That way we can continue it into the function. Okay, let's try another one. In this case, u is equal to x, so u prime is equal to 1. This is what we used to see when we do power rule. So remember, our derivative is going to be u prime n to the u to the n minus 1. There's your normal power rule. We just have to take the derivative of u prime as well. So we get y prime equals 1. I just noticed what I wrote here. U is x. I even said it was x. U prime is 1. So n, so negative square root of 2 times x to the negative square root of 2 minus 1. And no, you are not changing these to fractions or decimals or anything like that. They are arbitrary real numbers. We just can't, they're irrational. We can't, so we're just going to leave them alone. We're not going to fight it into getting it to something else. Okay. Oh, this is a kind of short video. Maybe I can finish this up in a 2-day period. We're going to try it. Okay, power rule of arbitrary real numbers again. Well, at least that was too soon for our bell work, but anyways. 2 plus sine of 3x to the pi power, find dy dx. This is 100% chain rule, so we want to make sure we have it on there. Even though we know this is going to be u prime n u to the n minus 1, that's going to happen all in the chain rule, but we have something inside of something inside of something. So you can see that we have the 3x inside the sign, all of this mess inside of the parentheses, which gives us pi on the outside. So u is equal to 3x, u prime equals 3, v equals 2 plus sine of 3, I'm sorry, sine of u. So v prime equals cosine of u. And then s of v equals v to the pi power. So s prime at v equals pi v to the pi minus 1. And all of this multiplied together will be your derivative. So y, well, let's say we said dy dx. dy dx is equal to, get my constants together, so 3 pi cosine of 3x times v, which is everything inside, 2 plus sine of 3x to the pi minus 1 power. So if we were to find what is, we know where n is pi. We know u is this guy right here to the n minus 1. The u prime was the 3 and the cosine of 3x because we had to take care of both of those derivatives. But there we are. That's what we have. Okay, and the last little bit that we have is logarithmic differentiation. Okay, sometimes the properties of logarithms can be used to simplify the differentiation process, even if logarithms themselves must be introduced as a step in the process. The process of introduction of logarithms before differentiating is called logarithmic differentiation. Okay, a lot going on this one, but it's kind of fairly simple. We're going to step it out on the very first problem. The very, very first thing that you need to do, let me make sure I don't miss any of those notes, is do a natural log on both sides. Natural log both sides. Now I'm going to change colors on each one of my steps so that you can see where I did it. So natural log of y equals natural log of x to the cosine of x power. There, step 1, done. Step 2. In step 2, we're going to bring down the power. Step 2, bring down power. So we're going to take this cosine of x, and we're going to move him down. This is one of those rules of logarithms that you will use a lot in calculus. So now we have the natural log of y equals cosine of x times the natural log of x. Okay, step 3. Step 3 is your derivative. So on here, natural log of y would become 1 over y dy dx equals, and we have a nice little product going on over here. So our product rule, we're going to have u equal cosine, so u prime is negative sine, and v is equal to the natural log of x, and v prime is 1 over x. Because remember, the derivative of natural log of x is u prime over u. Derivative of x is 1, and then u is x. So u prime v plus v prime u gives us negative sine of x, natural log of x, plus cosine of x over x. Okay, a little bit more going on there. Most of the times you don't have a lot going on with regards to that. There we go. Let's see, purple, a little black. Okay, step 4. Isolate dy dx. So anyways, I'm going to multiply both sides by y. So I had dy dx is equal to y times all of this, and I don't like my negatives first, so I'm going to put cosine of x first. Cosine of x over x minus sine of x natural log of x. And we have one more step. Step 5, substitute back your value of y. We know what y is. Y equals x cosine of x. So my derivative in the end is dy dx equals the y, which is x to the cosine of x power, times cosine of x over x minus sine of x natural log of x. And there's our derivative. Now, hopefully you're not sitting there going, oh, this is really a lot, this is really a lot. I'm watching the time going, maybe I should have made this a second video or third video. But I only have a few examples of these, so, and then we're done. So a couple of little bit of long videos. Okay, dy dx for x to the x power. Steps are going to be the same. I'm just not going to write them out again. So the very first thing we need to do is natural log both sides. So natural log of y equals natural log of x to the x power. There's the first step. Second step is to bring our power down in front. So we get natural log of y equals x, natural log of x. Now we do the derivative. Derivative of natural log of y is 1 over y dy dx equals, and we have, here goes, side work. I had to squeeze it into that last one. U equals x, so u prime equals 1. V equals natural log of x, so v prime is 1 over x. And don't forget, u prime v plus v prime u. Multiply this way, we get natural log of x plus, and then we multiply this way. I do want to point out you're going to get x over x or 1. And if you want, wait, how'd that happen? Because I'm multiplying u times v prime. X over 1 over x gives me x over x, which is just simply 1. Step 3, step 4, isolate dy dx, so multiply both sides by y. So I get dy dx equals the natural log of x plus 1 times x to the x power. This one didn't seem as bad because we didn't have trig functions to worry about. There was a lot more going on with the other one. But there you go, have on that one. So this one here, if you're going, when am I going to use logarithmic differentiation? How am I going to know to use it? You're going to have a variable in the base and a variable in the exponent. So you have the variable twice, and what you have to do is be able to pull that variable down. Okay, one last example. Sine of x to the x power. Step 1, y equals, natural log of y equals the natural log of sine of x raised to the x power. Second step is to take my power and move it in front of the natural log. So I have natural log of y equals x natural log of sine of x. Take the derivative of natural log is 1 over y, and since it's y, we have to write dy dx equals, and then we have our side work. So if u equals x, then u prime is 1. If v equals natural log of sine of x, then v prime, keep in mind this is u prime over u. So for v, my u prime derivative of sine is cosine and over sine. And this is a trig function or identity you should know. Cosine over sine equals cotangent. So that was for this one. And our normal derivative is u prime v plus v prime u. So this way I'm going to get just the natural log of sine plus, and I multiply this way, I get x cotangent of x. There's our step 3. Step 4, multiply both sides by y. Anyways, you're isolating your dy dx. So I get dy dx. So I did that, and then once you have that done, replace your y value. So I have natural log sine of x plus x cotangent of x times my y value of sine of x to the x power. And we're done. All of these at least are done the same. It's just got that derivative going on. Every one of them has natural logs in it. So it's still all good. All right, there we go then. We have finished up this section for 3.9. And good luck on these problems. 20 minutes.